Hello and welcome to this special CodeRage XII session on managing technical debt. Presenter today is Steve McConnell. He's the CEO and Chief Software Engineer of Construct Software. Steve has a master's degree in software engineer from Seattle University and probably most famously known for his book Code Complete. It was originally published in 1993, if you can believe that. Still a great book and very, very relevant today. He was the editor of the Best Practices column in the IEEE Software magazine, and then later editor-in-chief for the whole magazine. All of his books together have been published in over a dozen languages and sold over 1 million copies, which is quite a feat in the world of software development books. He's also voted one of the 3 most influential people in the software industry alongside Bill Gates and Linus Torvalds, which I think is quite a fantastic recognition, and certainly I think well-deserved. Construct Software is a company founded by Steve over 20 years ago. They provide consulting, training, thought leadership, and resources around software development. They have a number of recognizable clients, including Microsoft, IBM, Intel, and others. They have an on-demand training platform, cxlearn.com, and they're based out of Bellevue, Washington. You can find more information on the website at constructs.com. Now, I thought I'd real quick tell you about some of Steve's books. His first book, like I said, was Code Complete, originally published in 1993. The second edition, which is the cover you see here, was released in 2004, and it continues to be the authoritative book on handbook on software construction. Software construction is kind of the term that he introduces within that book, and is what the book focuses on, what software construction is and how to do it. I remember actually we were reading it in our software developer group, this book. We started reading Code Complete first edition, and right as soon as we started our book club reading around this, the second edition came out, which was kind of interesting timing. So I ended up buying both copies. I don't know if I still have the original edition or not, but I do still have the second edition. It's a great book, great reference, highly recommended. If you haven't read it, you really should check it out. His second book, followed up with, is Rapid Development. It covers taming the wild software schedules, which, if you've ever tried to schedule software development projects, you know that they are quite complex and quite a lot involved in scheduling those appropriately. His third book was Software Project Survival Guide, How to Be Sure Your First Important Project Isn't Your Last. And it was followed up with, in 1999, by the After the Gold Rush, which looks at creating a true profession of software engineering. That was then republished in 2003 as the Professional Software Development book, and it focused on shorter schedules, higher quality products, more successful projects, and enhanced careers. His most recent publication was in 2006, Software Estimation. It focuses on demystifying the black art of software estimation, which, as I mentioned earlier, if you've ever tried to estimate or schedule a project, you know software development projects, they are quite complex and quite a lot to that. And so a great book on the subject of estimating software projects correctly. As I mentioned before, in total, his books have sold over 1 million copies in a dozen languages. And with that, let's turn it over to Steve for his presentation on managing technical debt. We'll note that after his presentation, which is about an hour, we'll also have a live Q&A with Steve to discuss managing technical debt, as well as any other topics that Steve is an expert on, which is quite a vast array of topics, whether it be his books or software development in general, software construction, etc.
Thank you for that introduction. Today we get to talk about a relatively new topic, technical debt, but I think while the name is new, the phenomenon it describes is certainly familiar to lots and lots of software developers. Let's see. I guess we should first define our terms. Technical debt refers to a design or construction approach that's expedient in the short term, but that increases complexity normally and is more costly in the long term. And I think there are several reasons to discuss technical debt. One reason is that it helps to educate the technical staff about how business makes decisions, Related and just important reason is that it helps to educate the business staff about some of the business implications of technical decision making. It also raises awareness of an issue and understanding of an issue that's often buried in deep technical considerations, but the benefits from being exposed at a little bit more conspicuous level. It also allows technical debt to be managed more explicitly once we throw it out on the table and look at it and talk about it. I think the analogy comparing technical, suboptimal technical work to financial debt, that analogy is quite rich and ends up producing a lot of insightful parallels. We can extend the metaphor very far and still find benefit in it. And so that's what we want to talk about today. So what I want to accomplish during this talk is I'd like to introduce the technical debt concept in a bit more detail. I want an idea of what's possible once you start really making use of this concept. And I also want to give an idea that what we talk about during the next hour or so is really just the tip of the iceberg. I think that there's a lot more that can be done with this concept once we understand the concept and start actually applying it. So here's what I'd like to cover this morning. I want to describe some common debt scenarios, which is basically a debt primer. And actually, I've collapsed those two sections, so we're going to talk about really just a debt primer. Get into some ins and outs of the technical debt analogy, talk about how you decide to take on debt, talk about how you track debt once you've taken on, talk about how you decide when and how to pay down the debt, and then summarize by summarizing what we can do with technical debt. So turning then to that debt primer, let's look at some of the reasons to take on technical debt and some of the reasons not to. And it's more complicated than this or more elaborate than this, but this is the top level view. Typical reasons that project teams or companies will take on debt is first because they think they can shorten time to market by doing expedient work now, even if it costs more to fix it or make it right later. Sometimes it's a matter of preserving startup capital, where a startup enterprise will have a small amount of money now and will anticipate having more money later, and getting to the point where they're actually generating revenue is really important, and so taking some shortcuts actually makes a lot of business sense. And a final reason is delaying development expense. There are often cases where $1 now and $1 tomorrow are not worth the same amount of money, or at least they don't represent the same level of cost to the business, and so delaying expense can actually make a lot of sense in some cases. So these are sort of the top-level generic reasons that companies take on technical debt. Now, having said that, there are also some reasons not to take on technical debt, and in particular, the reason that many technical staff are all too familiar with is that debt can create a vicious circle. You start out being behind schedule, and so in order to make your schedule, you take on debt. As you take on debt, that debt, due to the definition of debt, reduces your productivity. That reduced productivity leads to less time for new features, which puts you even further behind schedule. And so that circle continues and just gets worse over time. So that, I think, gives you a little bit of an abstract view of what debt looks like, or technical debt looks like. Let's look at some specific examples to really put that picture into clearer focus. Example of bad debt. Guys, we don't have time to dot every I and cross every T on this release. Just get the code done. It doesn't have to be perfect. We'll fix it after we release. I think that's a pretty common end of development cycle dynamic. Sometimes this produces the desired effect, and sometimes it doesn't. What it's guaranteed to produce, though, is a legacy of poor quality code that is either going to have to take time to get fixed later, or is going to be a drag on the project until it does get fixed. Okay, here's a better example, or example that's a little bit more favorable. We don't have time to reconcile these two databases before we ship, so we'll write some glue code that keeps them synchronized for now and reconcile them after we ship. I like this as a good debt example because it identifies a specific shortcut, and it also implies a plan for recovering from that shortcut. So I think that's quite different from the first example. Okay, another example of good debt. Our 6-month-old system was, or rather, our old system was crumbling, so we took on a 6-month refactoring or re-architecture project. After 6 months of work, We weren't able to converge a release, so we had to back out a lot of the work that we had done. The system we have now is a Frankenstein's monster that is buggier than the old system we were trying to replace. And I think this is a case of good intentions but maybe bad execution. We certainly have seen this in our consulting practice a lot, where project teams will take on a fairly large-scale re-architecture or refactoring project, certainly with the best of intentions, but without a really clear business focus. That tends to create more debt than it pays off, and I think this is actually pretty representative of what we have seen over the years. Our final example, good debt, is suppose you're on a project team and we say there's a right way and a wrong way to fully support the next version of Android. The right way will cost us 100 staff months now. The wrong way will cost us 10 staff months now, plus 2 staff months in added production support for every month the system is in production. Since we're planning to completely replace the system in 18 months, lifetime cost of the wrong way, or quote wrong way, is 46 staff months, which is cheaper and quicker than the 100-month approach. So in this case, the quote wrong way actually turns out to be the better option. I think this is actually a good example because we're making a very conscious decision, well aware of what the upside is and what the downside is, and we're taking on those costs very consciously, and we end up making the decision on essentially a business basis of saying it's a smaller investment and do it this way, and since the systems are going to be retired anyway, it doesn't make sense to invest more heavily. So this would be in the camp that I would describe as overall a good example. Now, for your reference, I'm not going to talk about these now, but if you want to review the slides after the talk, there are all kinds of other examples we could give of technical debt. At the code level, it could include things like violations of coding standards or creating duplications in the code. Style drift, the idea that coding standards tend to change over time in long-lived code bases. Certainly we can have technical debt issues at the design level where we don't have a coherent design or we have inconsistent design approaches. At the testing level, too, we can have brittle test suites or incomplete test coverage. So there are a lot of different ways that technical debt can arise on a project. Let's talk a little bit about, continuing with our primer on technical debt, let's talk a little bit about different sizes and frequencies of debt. We can have technical debt that's analogous to consumer debt. That is something like credit card spending, where if you're using credit cards in an unhealthy way, you're using them on a day-to-day basis to pay for day-to-day living expenses, but you're not paying it off at the end of every month, and that just accumulates debt over time, in many cases with a high and burdensome interest rate. A healthier use of short-term debt like consumer debt would be just for convenience, where you have the discipline to pay off the debt at the end of every month. That could actually be a positive instead of a negative. So the term of the debt doesn't necessarily affect whether the debt is a good thing or a bad thing. We could also have less frequently incurred debt, such as major purchase debt. An example here would be a car loan. And the idea here behind the debt is that if we have to pay for the car all at once, it's basically that would be a misalignment of the cost of paying for the item versus the usage of the item. If we're going to drive that car for 5 years and we take on a loan that we pay off over 5 years, then we're basically matching our payment, the time of our payment for the item, to our consumption of the item. And that can actually make a lot of sense. We want to smooth out our cash flow and have it match our use of the asset. And so that actually can work fine. Finally, we have asset-related debt. That's like a home mortgage, something that we expect to appreciate over time in normal circumstances anyway. And this is also a case where we want to try to use debt to match our cash flow over a period of time to our consumption of the item over a period of time. And sometimes, not always, but sometimes this is based on a bet that our personal income will increase in the future. Sometimes people will take on a home mortgage that's tough for them to carry at the time, but they believe that their income is going to increase, and so that mortgage that seems so burdensome now won't seem so burdensome 10 years from now. I'm sure a lot of us have parents or grandparents who bought their house 20 years ago, and their current house payments are, $79 a month or something ridiculous like that, and that probably seemed like all the money in the world to them when they took on that mortgage 20 or 30 years ago, but now it really literally seems like nothing. And that's basically what we try to accomplish with technical debt sometimes too, is take on debt at a time when spending more money now seems like an awful lot of money to spend, with the expectation that it won't seem like as much later on. So we've, I think, just to talk about the fact that the frequencies really can be broken into two categories. Short-term debt, then, we normally take on with the expectation that we're going to repay the debt in the short term, and usually taken on to cover temporary issues like if we're a business and we need to make payroll and we've done a lot of work and we're expecting payments from our clients, that means we've got receivables. We can take on a short-term financing to cover that gap between when we receive payment for the work we've done versus when we need to make payroll. Long-term debt we use to finance longer-term investments, and there's usually some expectation that we've got a strategic reason for taking on that longer-term debt. So we might be taking on longer-term debt to finance a major purchase like a new manufacturing plant, or to finance a major initiative such as development of the next generation of video drivers. We expect the payoff of those, say, next generation video drivers to be received over a period of years, and again, it makes sense to match our cash flow in paying the development of those with the return that we expect to get over time, or it can make sense. So, why would we take on debt then? Let's put a little bit more meat on the reasons that I gave at the beginning of the talk. The reasons that companies take on debt, at least the rational reasons, are usually related to some combination of expected value, and opportunity cost. Expected value is a concept from statistics that is simply the probability of an amount occurring times the amount. So, for example, I'm in Washington State in Bellevue near Seattle, and we have a state lottery called Lotto. The odds of winning the game called Lotto are 1 in 27,000. That is a 0.003% chance of winning $1,000 for every $1 play. The expected value of one play is $1,000 times 0.003%. It's actually 0.0037%. But anyway, the expected value of one play is about 3.7 cents. What that means is I shouldn't spend more than 3 cents on any given play. If I spend 4 cents, I expect, in the statistical sense, I expect to lose money. And so in software, the expected value, that is the expected cost of doing a particular task, is a lot lower in the future if I only might do it sometime in the future than if I'm actually doing it right now, because we have to discount it by the probability of actually doing it. So if I'm going to take on a task and I know I'm going to do it today, then I'm paying 100% of it. If there's only a 50% chance I'll take on that task at some point in the future, then the expected value is only 50% of the cost. And so that gives us a reason, that gives us the concept of expected value. Present value is also a relevant concept, and this is based on the idea of, would you rather have $100 today or $100 in 2 years? Most people would rather have that $100 today. And the idea there is that $1 today tends to be worth more than $1 in the future. Now, similarly, would you rather pay $100 today or $100 in 2 years? Well, we'd probably rather pay the $100 in 2 years rather than paying it today for the same reason. We expect that dollar to be worth more now than it is later, and so we'd rather get the money sooner and we'd rather give the money later, all other things being equal. And so software projects, when we calculate present value, we also have to talk about opportunity cost and expected value and some other factors. Opportunity cost then is the final reason, and opportunity cost is basically what else could I be doing with this money or resource if I wasn't doing this thing with it. So what is the cost of foregoing these other opportunities I might have? And so the expected value of the other things that you could be doing with that money or that resource is the opportunity cost. And this really is the key concept in time-sensitive markets, like when you need to get a software capability to market quickly, or you're trying to minimize the cost incurred during a startup phase. is that a dollar you spend now is really not the same as a dollar later, especially if that dollar you spend now delays your project in such a way that it might cause you to lose $10 or $100 or $1,000 in revenue because you get the software out later rather than sooner. And so sometimes technical staff will think their businesses are irrational because they are willing to save a dollar now even if it costs $5 in additional maintenance later. Well, that's not necessarily irrational. If that dollar you save now opens up $10 in revenue rather than $1 in revenue, then even if you do have to pay $5 in increased maintenance costs later, that's still a good decision because you're still ahead $5 because of the extra revenue you got, and so that needs to be taken into consideration too. So in terms of the reasons we take on technical debt, the most common reason, I think, clearly is opportunity cost, because this idea of shortening time to market, preserving startup capital, or just delaying development expense. Now, this really brings us to a discussion of different categories of technical debt, and this, I think, is important because some of the categories are much more desirable than others. We have unintentional debt, and that's the debt that we incur due to low-quality work. And this really can be divided into two kinds. Honest mistakes, such as, I wish we'd known Framework 2.1 would be so much better than Framework 2.0. Oh, you didn't know. There was no way that you could have known. It's an honest mistake. It doesn't change the fact that you actually incur some debt because of developing on that lesser framework. But then there are also careless mistakes, like design. What design? Design is for sissies. Well, that's not an honest mistake. That's a mistake that you make through sloppy practices, and so you can get unintentional debt that way as well. I think we want to avoid unintentional debt, period. Some of it's easier to avoid than others. The honest mistakes are hard to avoid, but the ideal here is to avoid unintentional debt. Intentional debt is debt that we incur on purpose, and this, I think, is useful to break down into short-term debt and long-term debt. And short-term debt we usually take on reactively for tactical reasons. Typically in order to support getting a particular release out the door in a particular time frame. And I think in short-term debt it's useful to differentiate between focused short-term debt, which are individually identifiable shortcuts. That is, per the earlier example, we're not going to try to reconcile these two databases before we ship. We'll reconcile them after we ship. And I think those are acceptable because we can identify them, we can put them into a product backlog or into a defect log, and we can get them on the list so that we know what they are and we can fix them at a later time. Now, in contrast, unfocused short-term debt is what happens when somebody says things like the other example I gave earlier, which is, guys, we don't have time to dot every I and cross every T, just get this thing out the door. Well, that leads to taking numerous tiny shortcuts that are untracked, and those are almost impossible to go back and fix after the fact because we don't even know where all of them are. And fixing those is tantamount really to doing the project over, and we're rarely going to get permission to do that. Okay, the other kind of intentional debt is long-term debt, and that's usually incurred proactively for strategic reasons such as making invest in one platform versus another or something like that. Out of these kinds of debt, the only kinds I think are really a good idea to take on intentionally anyway are focused short-term debt and long-term debt. And I think that's really it. These other kinds of debt are problematic. They're difficult to track. They're difficult to pay off. They tend to be a drag on the project, and so I don't suggest taking on those other kinds of debt. This brings us to some more detailed ins and outs of the technical debt analogy, and I think these can be instructive as well. One is the concept of debt service. If you have a real financial debt, you're going to have interest that you pay on that debt, and you have to pay that interest above and beyond the principal. That is, in essence, a service charge for being allowed to take on the debt. Now, interest can be structured in different ways. You may have to pay it off periodically. You may have to pay it off all at once when the debt is repaid. But I think in the technical debt context, for something to qualify as debt rather than just a design trade-off, there has to be some kind of interest. There has to be interest that's paid on an ongoing basis. There has to be interest that's paid all at the end. But if there's not some notion of an extra payment above and beyond just doing the work a good way the first time, then it's not really debt. It's something else. So here's an example. Is this technical debt? Quote, we don't think we're going to need to support a second platform for at least 3 years. So this release can be built on the assumption that we're supporting only one platform. If we need to support a second platform, we'll do the work later. Well, this example of delayed work, to be sure, but I don't think that all delayed work is debt. I think this is just a case of sequencing the work, and unless it creates extra work to do it that way, then I don't think we can characterize that as debt. I have in a feature backlog, features that we've deferred, features that we have cut in order to make a release. These are not necessarily debt. It comes back to this question of, is there an interest payment? And if not, then it isn't really debt. Now, another concept that's interesting to apply to technical debt is what's called the debt service coverage ratio, or DSCR. And in finance, this is a specific common measure of financial health. And in software, the analogy to DSCR is really the ratio of work that you spend on advancing the software versus the work that's needed to keep the software from sliding backwards. And so an example of that might be something like this. Quote, we have a legacy code base that's 10 years old. Out of our $3 million IT budget, we spend about 50% just making the changes necessary to keep the production system running. So there, the DSCR is pretty high because we're spending half of our budget basically just treading water, keeping the system from going backwards. And so that's something we should probably think about. Is that a healthy level, or is there something we could do to pay down the debt so that the debt service coverage ratio isn't so burdensome? Credit rating is another interesting concept to apply to technical debt. In financial terms, credit rating tells you what borrowing power different consumers or businesses are going to have. A good credit rating gets you higher borrowing power. Well, I think in software, teams truly have different abilities to carry technical debt responsibly too. And if you have a team that's carrying a lot of debt due to low quality work, unintentional debt in other words, they will have less ability to take on intentional debt for strategic reasons than a team that has been more conscientious about keeping its unintentional debt low in the first place. And so this is one of the interesting points about technical debt, I think, is that we really want to minimize the debt we take on unintentionally so that we create the option to take on debt intentionally when it makes sense to the business for us to do that. Acquired debt, I think, is another relevant concept. We can have, it's not our fault, debt that was taken on for strategic reasons perhaps, but we weren't there making the decisions. Somebody else make the decisions, and we have to live with the consequences. You know, maybe you've bought into that debt, maybe you wouldn't. Sometimes I think we see this very commonly occur when one company acquires another company and they try to work with the acquired company's code base. You can actually acquire debt from that other company as part of what you get in an acquisition. Another relevant concept is 90 days same as cash. Sometimes this is an option. That is to say, sometimes if you pay the debt off quickly enough, there's no interest payment. So if you wait longer, there might be an interest payment, but if you pay it off quickly, there's not. And so the notion that a team is cranking toward a release, they take some specific identifiable shortcuts to get to the release, and then immediately following the release, they do that work and clean up the shortcuts. There might not be any extra payment on that. So whereas maybe if they wait a year, maybe it would cost more to get that same work done, but right after the release, maybe it's not any more work. So 90 days as cash really is, I think, a relevant concept. Monthly payments is another relevant concept. And I think one of the things we ought to think about when we take on technical debt is what is the threshold level of activity needed to make a minimum payment. Is the threshold activity really low, like we roll up a new version on the website? Is it high, where we have some hard costs, like sending out DVDs? Or is it high still, like we have to replace chips in a computer or replace a box on an airplane? Well, the ability to pay off debt depends in part on what the minimum payment is. And if we have even a tiny error, one that's easy to fix, only takes a few hours of development time to fix, but it requires us to replace a box on an airplane, well, that's going to be a very different decision than if we have the same kind of defect, or debt rather, that takes a few hours of development time, and we just have to roll a new version up onto the website. retiring debt is an interesting one. I think that, in my experience, teams normally find working off debt, that is, doing work that reduces technical debt, to be motivating. They feel like they're improving the system, and they get satisfaction later on when they work in that system that has experienced those improvements, and they get to work in a more satisfying way. Now, a special case here where we actually get a break in the analogy between technical debt and financial debt, and that is at the end of a lifetime of a system or end of service. When we retire a software system, unlike financial debt, all the technical debt retires with it. And for this reason, as we get a system that approaches the end of its life, cost justifying anything other than the most expedient solutions becomes increasingly difficult. If we know a system is going to be discarded 3 months from now, there's just no financial benefit to doing anything other than the cheapest thing that will keep it glued together for the next 3 months. Now, if that system is going to live for the next 5 years, calculation is different. But when retirement is imminent, that changes our decision-making, or at least it should change our decision-making about the permanence and quality and integrity of all the changes that we're making. The decision to take on technical debt is one that I think should be made deliberately. Here, what we usually find when we decide to take on technical debt is that we're comparing a trade-off between some good solution and some quick and dirty solution. Implicitly, when we decide to do a quick and dirty solution rather than a good solution, we are assuming that the quick and dirty solution is actually, in fact, quick compared to the good solution. And I think it's valuable to get those assumptions out and make them explicit rather than just having them locked in somebody's brain. So let's say in this example that we've decided that the cost of a good solution is 10 staff days. And so if we assume, I'm just going to assume for purposes of illustration, a cost of $600 per staff day. So this option is guaranteed to cost us $6,000 now. So that's the cost of the good solution. Option number 2, the quick and dirty solution, we've estimated will only cost us 2 staff days for the immediate work. And then the interest payments we expect will cost us 1 to 3 staff days until we get to the point where we implement the good solution. And in this case, the deferred cost to retrofit the good solution is actually higher than the cost to do it initially, in part because we have to rip out the bad solution. And so the total cost here ends up being 15 to 18 staff days. And so, but the cost now is only $1,200 instead of $6,000. The cost later, when we get to the point of doing the deferred solution, will be $7,800 to $9,000, and our total cost will be basically $9,000 to $10,000. So certainly higher than the $6,000 of doing the good option now. Now we could stop here, and in my experience, most developers and project teams do stop at this point, and they make a decision like, well, can we afford to spend the $6,000 now? If we don't spend the $6,000 now and we have to pay the $1,200 now, is it really going to be worth it to pay the extra later? And that's pretty much the extent of the analysis. The point I would make here, though, is that often there is another option, and what we should look for is an option that might be construed as quick and dirty, but that doesn't incur any interest payment. So there's no real cost of not fixing it as we go. It's just that there might be a cost of retrofitting the good fix later, but no ongoing costs that we incur as we go. So let's say here that the cost of a quick and dirty solution, which is slightly better than option 2, in that it doesn't incur an ongoing interest payment, is $1,800, and then the cost to retrofit it is still 12 staff days, just like option 2, and so total cost would be higher, $9,000, than the cost of doing it the good way first. But the key point here is that with the cost now of $1,800 and no ongoing interest payment, we don't actually have to retrofit the good solution. We can wait indefinitely if there's no ongoing interest payment for that. And that's really a big difference between option 2 and option 3. Option 2, because there's an ongoing interest payment or cost incurred, we're paying day by day, week by week, month by month for not implementing the good solution. With option 3, we're not making that payment. It just costs us more when we get to the point that we decide to do the good solution, but not until then. And I think often the best decision is option 3, but we don't, often don't do the work to come up with that. And I think this often comes down to basically how creative can people get about the design. And we may have to think a little bit harder to come up with a good design alternative that will support a quick and dirty solution, but that does not have an ongoing interest payment. So the key point here is really to avoid binary debt, no debt decisions. I think we usually have way more options available than that, and if we can really focus on zero interest options and give ourselves the opportunity to never pay off the debt, possibly, then we really want to do that. I think in general we should ask a number of key questions. We should ask, do we have estimates for the debt and non-debt options? If we don't, why are we even talking about taking on debt, right? We shouldn't be talking about taking on debt unless we have some quantitative notion that there's a benefit now to taking on that debt. A question we should also ask is, do we believe the estimates? Well, if we don't believe them, why are we taking on the debt? And then, of course, we should ask, how much do we reduce our effort now by taking on this specific technical debt? How much will the quick and dirty option cost now? How much will the clean option cost now? And how much will it cost later to replace the quick and dirty option with the clean option? Those are key points in the decision. Also, we should be asking, what will the interest payment on the quick and dirty option be? We should ask how that interest payment is structured. That is, do we have to pay it on an ongoing basis, or do we only have to pay it off all at the end? If we only have to pay it off all at the end, maybe we structure the project in such a way that that debt just gets retired when the system gets retired. We should at least ask the question, are there issues involved in paying back the debt, such as replacing the box on the airplane? Why do we believe it's better to incur the effort later than to incur it now? What's going to be different in the future than it is now that makes it more palatable to pay it off later than it is now? If startup mode and cash is king and we really have to preserve cash at all costs, well, we know it's going to be different later. If we're just in a normal business operation where we're in a mature business with a mature software system and we're on release 7 and we're going to be going into release 8 and then release 9, it's hard to make the argument, I think, that that dollar later is going to be any different than the dollar today. Can we track this specific debt? That's important because we need to be able to down the debt. We have to be able to know where the debt is, and so tracking it is important. Considered all the options, including any zero interest options. And then here's a key point that many technical staff have been burned by over the years. Who in the business is going to own the debt? He needs to take responsibility for the decision of taking on the shortcut now and owning the business value of that decision, the business value that says this is worth more now, even if we are worth enough now that even if we have to pay more later, it's a good decision. And that ultimately is a business decision more than a technical decision, I think. The technical job is to really inform the business about what the trade-offs are, but then the business's job is to make the decision about the cost of the dollars now versus later. It also brings up the question of how much debt is enough or too much. I don't think there's any one right answer, just like there's no one right answer for financial debt. Technical staff's attitude, in my experience, tends to be a little extreme. A lot of technical staff will say the only right amount of debt is zero debt. I don't think that's right any more than that's true for financial debt. Business staff tends to have a higher tolerance for technical debt, but as many of us have experienced, they also tend to have a shorter memory for the fact that we took on the debt, and we may have to put some structures in place to help the business remember the debt that it's decided to take on. And that's just part of the challenge of technical debt. I'd like to turn now to the topic of tracking debt, and I believe that all good debt can be tracked. By definition, any debt that we intend to take on, we should be able to identify individually, put into a product backlog or a bug list, and track it in those ways. We've seen some companies track debt by defects. We've seen other companies track them in product backlogs. And in terms of measuring the effect on the project, we've seen some companies that monitor project velocity, and they'll say once our velocity drops below a certain level on a per iteration basis, we'll make the assumption that the debt is getting to be too burdensome, and so they'll schedule an iteration to do some debt reduction. And other companies will monitor the amount of rework and simply track the amount of rework they're doing and use that as an indicator of the technical debt. We can certainly add up the total debt in a product backlog as one measure of debt. Some companies will look at their maintenance budgets or take some fraction of their maintenance budget and use that as a proxy for the debt they take on. We have one client that basically says we look at the backlog of customer-facing work and we age that in the aged receivable sense. And when we get anything that is aged beyond 180 days, that automatically goes to SEV 1 and becomes a top priority to fix. Even if it started out as a SEV 2 or 3 or 4 defect, once it gets to 180 days, because we don't want this debt to accumulate indefinitely, they just escalate it to SEV 1. I think it's useful to measure debt in money rather than features, just in terms of communicating with the business. If we can say 50% of the or something like 50% of the R&D budget is non-productive maintenance work, that really hits home at the business level because it's couched in terms the business actually understands. The decision to pay down technical debt is one that's important as well. I think good reasons for paying down technical debt are normally based on business need or business benefit. Bad reasons, and I don't really mean bad in any moralistic sense, I mean ineffective, that is reasons the business people won't accept, tend to be very technical sounding. And so examples of this are, a good example would be a scenario where we want to pay off short-term debt. We might make a statement like, we took some shortcuts to get the last release out the door, and now we need to clean up the code before we start writing new functionality. Okay, I think that's a reasonable scenario for paying down debt. Another example of a good reason to pay down debt might be debt service. Maybe we're incurring longer release cycles that are undermining business operations because of the interest payment on the technical debt. And if we can go to the business and say, we'll be able to get future releases out in 5 months instead of 6, if we can spend some amount of time right now reducing our debt, that's a rationale that is couched in business terms that a lot of businesses are going to be receptive to. Another good reason, debt itself in the form of low quality is undermining business operations. So the example might be something like, some of the, quote, shortcuts we've been taking have started to become visible to the customer, and the number of customer-reported defects has been increasing. To pay down our debt, we will have an increasingly difficult time assuring quality prior to release. Again, this is talking to the business in terms the business understands, basically quality. That can be compelling to the business. Another reason, another good example, the final good example I'll give you to pay down debt is debt in the form of a technical limitation is preventing access to new business opportunities. So the example here might be, if we spend X number of weeks working on technical infrastructure in area Y, we'll be able to add features A, B, and C, which we can't add now because of shortcuts we took when we originally implemented area Y. And so again, this is couching in business in terms the business understands that there's a capability that the business wants or the customer wants, that is features A, B, and C, that we can add because our work in area Y is blocking that. And I think this is kind of rationale that businesses tend to be pretty receptive to. Now, some things to avoid in giving reasons for paying down technical debt are technical sounding terms. I think businesses are rarely motivated by terms like saying the design is bad or old or crafty or not object-oriented or not agile. Those are not business terms, and the business is typically not going to see the business value in having a design that is not, quote, crafty or not, quote, agile. And so I think the more we can tie the justification to business benefit, I think the better success we're going to have in convincing the business that we need to do it. I also think that we don't have to justify every single initiative in paying down technical debt one by one to the business. We can just plan in some debt reduction as part of our normal workflow and part of doing a good job. That is to say, if we're doing, say, monthly iterations, let's say that we're in an agile context, we're doing, I'll just make up a number here, we're doing 50 story points per iteration, we might just say we are going to pay down, let's say, 3 to 5 story points worth of technical debt iteration. So we just build that into our normal iterative development process and have some fraction of the work, maybe it's 5, 10, 15%, 20% that just goes into paying down debt. And that does not have to be visible to the business. If it becomes visible to the business, it's easily defensible. That is, this is part of doing a good job, is maintaining the quality of the thing we're working on. It's like we don't have to rationalize taking our car in for scheduled maintenance. Likewise, we shouldn't have to rationalize some fraction of our efforts going into keeping the system operating at an effective level. So what are some approaches to actually paying down technical debt? We've seen a number of approaches with the companies we've worked with. You can certainly do a debt reduction iteration immediately following a full product release, especially if you've taken on conscious short-term debt through individually identifiable shortcuts. That is a very rational way to do that. It's timely. The team tends to find it satisfying to have a chance to go back and immediately clean up the work that it probably at some level resented doing in a slipshod way in the first place. And also it tends to be a time when teams could benefit from a little bit of a pause and before they jump right into the next release. So a debt reduction cycle can make a lot of sense, a debt reduction iteration. I just talked a moment ago about amortizing small debt payments into each iteration. I think that makes sense. I do think that it makes sense to require that above a certain threshold, one of our clients uses a threshold of 250 hours, that debt reduction initiatives need to be approved as separate projects. In our experience, large debt reduction initiatives don't tend to produce the intended results. They tend to end up being relatively unfocused refactoring initiatives or architectural improvement initiatives. And the Frankenstein system example I gave at the beginning of the talk is, in our experience, a pretty common outcome of those initiatives, that without a clear business objective on the table to focus the debt reduction work, the work tends to be unfocused. It tends to move the systems in system directions that aren't in fact valuable to the business. And so we've learned through the number of companies we've observed to be really, really cautious about large debt reduction initiatives that don't also have some increment of business functionality as part of the initiative. We've also seen cases where individuals will rotate through debt reduction duty. I think that in general, it's good practice to make the individuals that incurred the debt also be the same individuals that fixed the debt. It's efficient to do that. It's also a good feedback loop for the individuals, but that's not necessarily how it has to work. Some organizations will view that work as being less desirable, and so they'll have individuals rotate through on a month at a time or iteration at a time or a couple iterations at a time or something like that. And finally, the other possibilities that offshore resources can be used to reduce debt. The nature of debt reduction work is often different in some ways than the nature of doing new development work, and in some cases it might be hard to cost justify doing debt reduction work with onshore resources, but if you can possibly assign some of that debt reduction work to lower cost offshore resources, sometimes you can justify doing debt reduction work that you couldn't otherwise justify doing, or you'd have a harder time justifying doing. Well, that's been a pretty quick tour of the technical debt universe, and so in summary, what can we do with technical debt? We can do a lot of things with it. We can talk with technical staff about it. We can communicate to business staff the implications of debt, and I personally have found that business staff tends to be highly receptive to this concept. It makes sense to them and they get it. We can measure the amount of debt by identifying the concept of technical debt. It gives us a way to think about it. We can make explicit decisions about whether we should take on more of the debt. We can get input from the business about whether the business believes we should have more debt or less debt and what impact on the business that debt is having. We can strategize how to avoid debt. We can track the debt. And we can make explicit decisions about when and how to reduce the debt. And I think all of these are good reasons to talk about technical debt. So with that, I am going to hand back the microphone, so to speak, to my colleague and open the floor for questions.
Okay, fantastic. Thank you, Steve, for that great session on managing technical debt.
My pleasure.
I'm kind of wishing I had a way to hand my copy of Code Complete through the GoToWebinar system here so you could sign up for me, Steve.
If you can figure out how to do that, I'll be impressed.
Yeah. I'll have to come up with some sort of like system where you could use a robotic pen remotely to sign it, maybe, or something.
Sounds great.
Have you seen this sort of analysis in practice, especially at like enterprise level government or private business IT systems? I guess in practice.
For government level, I would say no. For a private enterprise, yeah, I think I gave examples during the talk of companies or teams that we'd worked with that had used this sort of approach. So, yeah, I think various aspects of it. I don't know that. I mean, I gave a lot of different variations in the talk, but we certainly have seen larger project teams and organizations that track debt numerically, put it in product backlogs, and that kind of thing.
Yeah, it's been interesting. I've worked at a few different places over the years, and I found it's interesting how much variation you see on the way different people do product management, right? So I've seen some places that do track technical debts, other places that do track like churn, for example. They say, well, we have X number of lines of code changed, and we have a typical line of code to bug ratio that looks like this, so therefore we need to plan this much time for bugs. I'm like, oh my goodness, that's amazing, that they have that level of management.
Right.
Do you see certain programming languages as more prone to creating technical debt than others?
That's a good question. I don't know. I do think that there are communities of practice that have more to do probably with types of software being developed and that happen to be associated with particular programming languages, but I wouldn't really chalk up the debt accumulation to the programming language per se. I would chalk it up more to the community of practice. So if we're working with a company that is doing safety critical embedded systems, we don't tend to see as much technical debt accumulated in companies like that just because there's such a premium on quality in the first place. On the other hand, if we see an in-house business systems organization, that kind of organization might be a little bit more prone to accumulating technical debt, but I wouldn't chalk, and those are probably going to be using different languages. So the in-house business systems team is using a different language than the embedded safety critical team. But I wouldn't say that the debt accumulation is a function of the language they're using. I'd say it's a function of the area that they're practicing in.
Yeah. I think that's a good point. I know that a lot of times I've been involved with conversations with people, and they're like, "Oh, we're switching from this to this because this language this language is faster, or this database is faster." Like I remember a lot of people are like, when NoSQL came out, they're like, "Oh, well, NoSQL databases are faster, so we're going to switch from SQL Server to NoSQL because it's faster." It's like, well, it's a different problem, and so by switching languages or switching databases isn't necessarily going to give you the result you need to apply, like you said, the practices and your methodologies and such around that. So
yeah.
How does Agile compare in the ability to manage technical debt or other methodologies? What methodologies would you say tend to be better in that?
Yeah, I think the Agile question is an interesting one just because we see so much variation in implementation of Agile practices, and I think if a team is making disciplined application of Scrum in particular and following the discipline of driving the software to a potentially releasable level of quality each iteration, then we don't tend to see a large accumulation of technical debt. But that is a high discipline aspect of Scrum, and so when we see teams not implementing Scrum with fidelity or implementing Scrum with low fidelity, I think that high discipline aspect is one of the aspects that tends to fall by the wayside. And so in a average discipline implementation of Scrum or low discipline implementation of Scrum, yeah, in that case we do see accumulation of technical debt. Is that because of the application of Agile practice? Well, really, it's due to the lack of application of disciplined Agile practice, really. So I guess I would say, I don't know that I really see more debt in an Agile context or less debt in an Agile context. a lot of it really just depends more on how disciplined the team is. Likewise in a more sequential context, if a team is making a high discipline use of good practices for that style of development, that is to say they're using code reviews or formal inspections, then they're not going to accumulate much technical debt. But if they're making low disciplined application of practices, then yeah, they'll accumulate some technical debt. I think in either case, the factor is not really what is the development approach they're using in terms of agile versus sequential. It's really more about, are they doing the practices with good fidelity in either case.
I like that. That's good. It comes down to the fidelity and the discipline. Yeah. Christopher wants to know if you have any new books in the works.
So what I have in the works currently is a lecture series, which is available at ondemand.constructs.com, and it's called Understanding Software Projects. And this is really my attempt to capture a lot of what my company has learned over the last 20 years, what I personally have learned in working with companies over the last 20 years. And the approach in the lecture series is to describe what I call the 4 factors life cycle model, and really explain with quite a bit of depth the impact that size, defects, human variation, and uncertainty have on software project outcomes. And I think my position throughout the lecture series is that if someone deeply understands the impact that those 4 factors have on software projects, then they actually will deeply understand what makes software projects work and what makes them sometimes not work so well. An awful lot of the discussion that I hear, see online and hear people engaging in and so on, I think could benefit a lot from understanding the impact that these 4 factors have. And a lot of times people will confuse cause and effect, and some of that is due to not understanding the impact that the 4 factors have and how they interact with each other. And one current example, which I'll be giving a talk on next week, is really not understanding the effect that size has on software project dynamics. And we talk a lot about scaling Scrum and scaling Agile practices, but I think in those discussions there's a limited understanding of what is involved in scaling in general before we even start talking about the fact that we happen to be using an Agile development approach. And so I think, anyway, so that's what I've been working on, and those lectures are coming out every few weeks, and as they come out, the new ones are available for free. We've got about 40 of those lectures out at this time, and so I encourage people to go check those out. Again, the name of the series is Understanding Software Projects, and that can be accessed from ondemand.constructs.com.
I went out. I was actually watching a few of your sessions out there on the Constructs on Demand. There's some good stuff on there. I really liked it, so I was glad to see you doing those. They seem very, very informative. How do you see microservices in the mix for reducing or creating technical debt? Are they a better way to mitigate, or are they not so much?
Yeah, I don't know that I have a real perspective on that at this point. I think that's a new enough area that I personally couldn't say that I've accumulated enough experience to make a comment on that one way or the other.
Are there certain practices beyond? I mean, I was trying to think of, like, we had Uncle Bob on yesterday, and he talked. We talked about solid principles and some of these best practices that have been around for a long time. Do you see following these sort of best practices having a good impact on it? Is that kind of, you talk about the whole discipline and fidelity thing?
Yeah, I do. I think, I think in general, we tend to get kind of hung up on details of specific approaches, but I think the main factor is a team actually making any kind of good faith effort at all in any way, shape, or form whatsoever to think about their designs and think about their technical approach before they just begin writing code. And I think that on the margins, if you are really sophisticated about the design approach you're going to take, that there are better ways to approach design and worse ways to approach design. But that really isn't the battle that the industry's been fighting for my whole career. The battle the industry's been fighting my whole career is the battle between total seat of the pants, just start coding, versus actually spend a little bit of time, formally or informally, and do some thinking ahead of time about how we're going to approach the project. You know, the joke is that when I started programming in the 80s, people talked about structure design, but really just engaged in code and fix. And then in the 90s, people talked about object-oriented design, but really just engaged in code and fix. And for the last 15 years, people have been talking about agile development, but really, a lot of people are still just engaging in code and fix. And so, you know, the buzzwords have advanced, but a lot of times the practice has not advanced along with the buzzwords. And so, really, you know, making some sort of concerted effort to at least try to do something reasonable is probably the main battle, and then I think the minor battle is what are the details of how we go about doing that.
Okay. Eduardo says, for a small one-man shop or a small team of 4 to 5 developers, what kind of mechanism do you recommend to keep track of debt and managing it effectively? Or is the stuff you're talking about, it seems like it's more focused to bigger groups, or what's your thoughts on that?
Oh, I don't know, 4 or 5 people, I think that's plenty big enough. We can certainly be doing high-fidelity Scrum implementation with 4 or 5 people. We can have a product backlog. We can be tracking technical debt by means of putting it into the product backlog. So, I think that size shop is, there's no reason that we can't be doing everything I described in the talk for that size development team.
Okay. How do you see managing technical debt versus correlating with just refactoring? Is that the same sort of thing as the idea of paying off technical debt would be what you might call refactoring as well, or are they different things?
Well, to use one of programmers' favorite words, I think those two issues are orthogonal to each other. I think that refactoring doesn't necessarily reduce debt. Refactoring, if it's done poorly, could increase debt. You know, I talked in the talk about these large-scale re-architecture projects or large-scale refactoring projects that we've occasionally seen go sideways and produce little or no business value, and you know, we've even seen cases where a project team will spend months on a supposed refactoring to improve quality, and at the end of that time will just throw away the work because they haven't converged to anything usable. So I don't think there's any guarantee of reduced technical debt just because we're doing refactoring. I think that refactoring for a specific purpose toward a specific end, you know, for the express purpose of reducing some specifically identified technical debt, of course that can be one of the tools in the toolbox.
Okay, so it sounds like identifying the technical debt and then working towards paying it off through refactoring is the key, not just how I'm going to do some refactoring if you're not actually working towards that goal. Then is that right?
No, I mean, you see individuals doing what I would really characterize as gratuitous refactoring. You know, they have some pattern that they really want to try that they've never tried before, and so they refactor towards some pattern that actually is not an improvement, and the refactoring change wasn't even needed. So yeah, I don't think there's any inherent value in the fact that we're refactoring. I'd also say that, you know, people use the word refactoring very imprecisely and sloppily, and the textbook definition of refactoring is that there's no semantic change in the behavior of the program, but it's just you know, ideally is a cleaner implementation of the same exact functionality. In practice, you hear people say refactoring, and what they mean is they're just modifying the code, including the behavior of the code. And if you're modifying the functioning of the code, then you're not really refactoring, or you're not just refactoring.
Not just refactoring. Okay. How does technical debt correlate with just a regular backlog of issues to be fixed? Is issues to be fixed backlog an indication of technical debt needs to be paid off, or are they two separate things?
Well, I tried to talk about that during the talk, and you know, for something to qualify as debt, there needs to be some notion of an interest payment associated with that debt. And if it's just an issue, if it's work you haven't done yet, but there's no sense of that work is going to cost more to do later, or you're incurring some ongoing cost because you're not doing the work now, then that's not debt. That's just deferred work. And of course, projects consist largely of, I mean, in some sense, you start on day one of the project, you build your list of work, and as you build that list of work, you're just creating a backlog of deferred work. That isn't debt, unless there's that notion of an interest payment attached to it.
Okay, all right, I remember that now. That makes sense. Have you seen the heavy JavaScript-focused web applications accumulate more debt compared to other systems like Java or .NET-based web applications?
Yeah, I don't know that I would say that I personally have seen that pattern. I would say that I think that the nice thing about scripting languages is that they allow you to move pretty quickly and create a lot of functionality quickly. The not so nice thing about that is that as you're doing that quickly, if you're not also doing it with at least a little bit of care, then you can be just basically coding faster than you can think and accumulating debt as you go. And I think there was but I don't think that's I don't know that that's a function of the language so much as is a function of the way that people tend to use the language, and I realize that's a little bit of a fine distinction, but I guess I would characterize that more as kind of like the generic hazard of using power tools. The attribute of a power tool is it's easier to cut the wood, it's also easier to cut your fingers off if you don't pay attention. And I think that's true with programming power tools as well. It's easier to get the right kind of work done, but it's also easier to accumulate bad work if it's not used with care.
So I hear you're frequently talking about the importance of discipline, fidelity, and care in what you're doing. So it sounds like that's kind of the main idea, is the more we can do that, the better. Although I like the way you talked about the strategy of taking on technical debt versus financial debt, right, and the balance of that. So, sometimes you don't have the time because of the financial constraints to do the, as much care as you want to now, but then you can do that later. So
yeah, so I would definitely not characterize that as a difference in the degree of care that's taken. I think if you're taking on debt with less care, then you're probably taking on one of those categories of debt that I've described as the kind of debt you should never take on. If you're not making a pretty conscious, deliberate decision to take on the debt, then you probably just shouldn't be doing it. Probably what that means is that you're working in a sloppy way that's actually going to cost you more, certainly in the long run, but will probably also cost you more in the short run. In other words, that shortcut does not produce the intended benefit of making the project take shorter. So, I tried during the talk to describe that, if we really are going to take on meaningful debt that actually helps accomplish that objective of shortening the time to a release or reducing the cost to a release, which are almost often the same thing, then, we're going to be quite deliberate about what debt we take on. And if the debt is something that, can be individually tracked, we can put on a list, we can track whether we still have it, we can track when we're paying it off, okay, then that is at least a good candidate for debt we might take on. But if it's not the kind of work that we could put on a list and track, then we probably have no business taking it on in the first place. We're just doing sloppy work that's going to bite us both later and now.
So it looks like we got most of the questions on technical debt covered. If anybody has any other questions on software craftsmanship or anything along those lines, or the understanding software project Steve's up to, that would be great as well. Anything else that you've got going on recently, Steve, that you'd like to talk about really quick?
Yeah, well, the Understanding Software Projects lecture series is definitely the thing I've been focusing on. Of course, the wrapper around that is just the whole move into online training. My company's been delivering training around the world for 20 years now, and the new delivery availability that we have through being able to deliver video content online, I think, is pretty exciting. People can access it anytime, anywhere. They can access it in amounts or chunks that are convenient for them, and I think that's pretty cool. I mean, I'm still a big fan of classroom training where you get to sit in a room and take a break from the day-to-day tasks and kind of think about what's working and what's not working and discuss that with your teammates, and that can be really valuable. And I kind of think that's the ideal, is to get a break from the work and reflect on it and go back re-energized and with some new perspectives and big to-do list of things to try. But for project teams that can't do that, they can't afford it, they can't afford to have everyone taking time off for training at the same time, the ability to go online and take training half an hour at a time, or take a class during your lunch break for a couple weeks, 30 minutes or 60 minutes at a time, I think that's pretty cool. So that's really what we've been focusing on for a few years now.
It is an interesting shift. We've just recently launched our Embarcadero Academy, where we're doing some of the same sort of things, where we have these smaller, easier to consume, on your own pace type trainings. But it's interesting, though, as we're doing this CodeRage conference, I've had people coming in and saying, oh my goodness, I really want to see this session, but I have a meeting right then, or my phone keeps ringing all day and I missed part of it, or something like that. And it's like, when you're at a conference, especially before we had our smartphones, you were at the conference, right? And it's very rare that something pulled you out. But now, as we're going towards the training, it's more convenient, but yet we tend to miss things. So being able to go back and see parts for sure is a big benefit.
Yeah, I do think that idea to kind of retrace your steps is useful, and of course that's a double-edged sword too, because I think we're more susceptible to distractions when we're taking training on our computer, and we look at an email and then we lose our train of thought, and then we have to go back up in the training. But yeah, at least we do have the ability to go back up, which we wouldn't have in a live setting.
Yep. There's a comment here. James says, thanks for helping developers communicate the software development process in a more meaningful way to their non-technical peers, as well as business executives, for example, financially, as in show me the money. I know that's something I've enjoyed. So I'm self-taught as a software developer, and the more I read books like Code Complete and things like that, it's more at helping me do the things I figured out the hard way, express that in a way that I can then communicate to others, whether it be other developers or stakeholders and such as well. So certainly it's a great benefit.
Well, I think I said this during the talk, but it's one of the things I really like about the technical debt metaphor. I think it's easy to get, I think, overly technical about the technical debt metaphor, or overly specific, or to put too much weight on it. But I think, to me, the biggest value of it is as a communication tool, because the notion of debt is pretty intuitive for most people, especially for most business people. It really does give technical staff a way to talk to business staff about what the real cost is of short-term technical thinking and what the impact of that is on the business. At the same time, I think one of the more common reactions to this talk from technical staff is people will tell me afterwards, oh, now I understand why actually it might make sense sometimes not to do the cleanest, purest solution, and why it actually might make sense sometimes for the business to ask us to take a shortcut. I realize now that that's not always irrational. Sometimes it can be a bad judgment, but there are times when that's a rational decision, and so I definitely think it helps communication in both directions.
That was a big takeaway for me watching this, is because in the past I've dug my heels in as the technical person and said, no, we have to do it the right way. We're not going to do it the wrong way. That's, and I used the term technical debt. I was familiar with that. But then when you start talking about the analogy of when it makes sense to us, like, oh, I can see that now. It makes sense, right? When you do the cost analysis, as it were. So I definitely got that benefit from this. Christopher's asking, says, are there any aspects of software craftsmanship you've advocated in the past but would not advocate today? And I'll share a little story with you. Back when, in 2004, the software group I was in decided to read Code Complete as a group and discuss a chapter each month with our meetings, and it was right when Code Complete 2 came out. So we got 2 chapters in, and then, oh look, here's Code Complete second edition. So some of us got the second edition, some of us got the first edition. And it seems like for the most part, it was very similar. There wasn't a whole lot that had changed as far as the overall principles have gone. But have you seen anything maybe that's changed since then, or what are your thoughts on that?
Well, it's a good question. I think that the way I look at it is not so much that the principles become obsolete and aren't needed anymore. The whole idea behind Code Complete was to try to identify language-independent, technology-independent programming principles that were useful, across technologies or across languages. And so I think, to the degree that I did that at all successfully, the material really should remain relevant over time. I think the thing that does happen, though, is that we tend to go through what I think of as technology maturity waves. And so, I don't know that we have a super new technology wave going on right now. Maybe microservices would apply, I'm not sure. But, we had, in the 2000 era, we had internet programming starting, and the internet technologies were really new. And cutting, bleeding edge technology. And I think certain kinds of technical practices work for that kind of leading edge technology. And now that we're, almost 20 years into the internet, we've more than 20 years in small scale, but around 20 years on a larger scale, it's not really bleeding edge technology anymore. There are pockets that are bleeding edge, but there's a lot that's really mature and well understood, and that calls for different kind of approach to more mature technology. And so, I think certain practices work better with certain kinds of technology. And the question came up earlier about JavaScript, and I think there are certain practices that might work better associated with scripting languages, but that would be overkill for other kinds of languages. It's amazing to me that if you had told me 30 years ago that I'd still talk to programmers who are using print statements to debug their code, or whatever the moral equivalent is of print statements in whatever environment they're using, I would have thought, no, we've got to have better tools than that 30 years later. But I still talk to programmers who are using some variation on print statements to debug their code in 2017, and it's kind of crazy, but some of the stuff has been around for a really long time. And if you're working in a new technology also tends to be kind of primitive in some respects. And in particular, the tool support in new technology tends to be kind of primitive. So, like one pattern we've seen over and over and over again is that as we get into new technology areas, the programming tools are first-generation programming tools, so the documentation's not great. The stability of the tools themselves is not great. The tools are not terribly sophisticated, so things like built-in optimizers and so on aren't there yet. And as time goes by and the technology becomes more mature, the tools also become more mature. So the documentation becomes more reliable, it becomes more comprehensive. You can find answers that you need on the internet really quickly. You do have, the tools themselves are robust and dependable. You don't tend to run into errors that are arising from use of the tools themselves. And then they just become more powerful. They have built-in really powerful optimizers and so on. And so, just the nature of the work changes depending on where you are in the technology wave. So I think sometimes people will go through a couple cycles like that, and then they'll think, oh, well, here's a practice that's kind of obsolete. But really what's happening there, I think, is it's not so much the practice that's obsolete, it's their environment that has shifted, and so the applicability of the practice is different than it was before. But time's going to go by, and then they're going to get back into more mature technology or less mature technology, and I think one of the things that's helpful is to be able to recognize when that happens and recognize that, okay, maybe it's time again to pull out some practices that I was using 5 years ago or 10 years ago and that I didn't need to use last year, but that actually are going to be pretty helpful next year.
I like that. That's good advice. I think certainly we do see those cycles like that. It's a question here. Do you have advice on when you have unskilled developers who are struggling to learn an architecture of a larger system?
Unskilled developers who are struggling to learn the architecture of a larger system. Well, I think they're kind of motherhood and apple pie answers to that. There's always one of the side benefits of design inspections, code inspections is getting people up to speed and cross-training and so on. Same benefit for pair programming too. Always combining more junior and more senior people, I think, is kind of standard good practice. I will say that having been doing this for a long time, I do think that there are just different people whose minds work in different ways, and some people are pretty good at grasping things at the architecture level, and I think in programming we have lots and lots of people whose strength really is more at the detailed level. And so, I think one thing to just keep an eye on for any given person is, are they the kind of person who really wants, needs, and is capable of understanding things at the architecture level, or are they the kind of person who really prefers to kind of stay in the details and has a great capacity for detail, but maybe doesn't value the architectural view, and may just not be their strength in being able even to see the architecture view.
Yeah, I've worked at places where they said, okay, there's the developer is the entry level, then there's the architect, and then there's the manager, and that's your career path. But I think there are people that are better at architecture, better at the development, and better at management are three separate skills and not linearly. So I think that's good advice to put people where they belong and what makes sense for them.
Yep, absolutely, absolutely. I think especially that distinction between manager and architect, and the idea that the manager is a promotion from architect. I think, technical organizations are going to benefit as much from a good architect as they are from a good manager. And it's a shame when you see an organization take somebody who really is a good architect and who maybe doesn't even want to be a manager, and then they, quote, promote that person into a manager. And I think, the joke that we've made in my company for years is that you basically hurt yourself twice. You deprive your organization of a good architect, and you inflict on your organization a poor manager. And so, the better organizations find ways to have parallel career tracks where there's a technical track and someone can move up on the architecture technical side, and others can move into more of a management track or more of a people-focused track and move up on that side. But certainly like to see organizations recognize that both are valuable career paths.
Yeah, yeah. Do you have any advice on creating the kind of culture you talk about in Code Complete, as far as what can you do to encourage others to become better coders, or in your organization encourage people to become better coders?
Yeah, I think that's an interesting way to ask the question. I actually believe that most software professionals take pride in doing a good job. And so I think it really is not so much a matter of like doing any arm twisting or convincing that they need to do a good job. I think they want to do a good job. I think in a lot of organizations, and this is very much bound up in the technical debt topic and the schedule pressure topic, is that individual contributors believe that they are not allowed the time to do a good job. They think their organizations don't want them to take the time that's needed to do a good job. So I think part of it is just the organization communicating that, we want you to do a good job. And then I think the second part of that is communicating, well, what constitutes a good job? And the kinds of things I talk about in Code Complete, if the organization manager or senior technical leaders in the organization communicate, yeah, this is what counts as a good job, making the code readable, understandable, focusing on simplicity, maintainability, collaborating well with others. It's not about how much work you get done, it's how much work the team overall gets done. If that gets communicated, then I think people adopt that as their definition of a good job, and because they want to do a good job, I don't think you actually really have to do much work to convince them that they should want to do a good job. They already think that. And so really the issue just comes down to making sure everybody's aligned on what the definition of a good job is.
Yeah, I like that. Let's see. So you mentioned that you haven't seen government departments do this kind of diligence around technical debt, and that there are some big projects that are. What seems to be working in those settings as far as managing their technical debt?
Yeah, so I think, just to be clear about what I was trying to say on that other point is it's not so much that I've seen lots and lots of government organizations and they're not doing anything with technical debt. That just isn't the kind of organization my company tends to work with most often. We get exposed to at least 10 times as many private enterprises as governmental entities, and so my exposure to the governmental entities just is not really that significant.
Okay, so it's not that the entities are that different, it's just what your exposure has been to.
Really, yeah.
What about your? I know you have the book on the recent book on your estimation, and that wasn't necessarily something we had planned to talk about today. But I know that I've been lots of projects. I remember one of the first places I worked, the manager would come and say, "How long do you think it's going to take to do this feature?" And I would put out a date, and then he would say, "Okay, I'll double that," and that was his method of estimation. And I've worked other places where apparently I was under-delivering things, and so I had to always pad my estimates by a week. Actually, I would always quote Mr. Scott, and I'd say, it would take a week, and that's if we were in space dock. That was my answer for all estimates after that. What are some good practices you've seen for estimating software development projects? And I know that's, a whole book or a whole lecture series on its own.
Well, it really is. It really is a whole book on its own, a whole lecture series on its own, and I think it's a case where I think glib answers are not super helpful on the estimation topic. I think there's a skill there that's not super hard to develop, but it does require some development, and estimation has been at least as strong an interest of mine as the Code Complete topic has been. I don't think it's anywhere near as big a topic as the Code Complete topic, but I think it's definitely benefits from a little bit of sophistication. I think that the single biggest piece of advice I could give on estimation is don't give off-the-cuff estimates. And by that I just mean estimates that are based on nothing other than just kind of searching your feelings and giving an answer that you think is about right. And certainly the bigger the task becomes, the less reliable those off-the-cuff estimates become. So if somebody asks you something that you think you can do in a couple hours, I think it's fine to ponder that and then give your estimate. If it's something that's going to be more than about a couple of days, you probably need to apply at least a little bit of structure to going about how you would create that estimate. And that's at a minimum. Really what you want to be doing is, over time anyway, is having some structure around the approach that you use to come up with the estimate, possibly having some group participation in how the estimate is created and then reviewed. Ideally, you'd like to have some sort of historical data that you're referring to in the creation of that estimate. So, and there are lots and lots of ins and outs of each of those points. And so, I think the big thing is, what's really unfortunate to see is organizations that are making literally multi-million-dollar project commitments on the basis of estimates that are created using extremely informal practices. And by extremely informal, I mean, sitting around for 5 minutes or 10 minutes and just sort of guessing at how long the thing will probably take. And it's really unfortunate to see that kind of thing happening, because it's bad business to make huge expensive business decisions on that poor quality of information. But it's also just painful to see that dynamics of that unwind as the project gets underway, and those estimates are with rare exception underestimates, and so the project teams then are put back into that technical debt context where they don't have enough time and there's pressure to take shortcuts, and things tend to go from bad to worse pretty quickly on those projects. And part of the reason that all starts is giving an unfounded estimate in the first place, so in an area where unfounded estimates tend to be low.
I've never been officially on the estimation side of projects, but as a developer, I found I think what you're saying about the idea that if it's like a few hours, it's probably accurate, but the longer the estimate, has been my experience, it's exponential how inaccurate it becomes. It's like orders of magnitude. So my general rule of thumb has been that whenever I'm estimating something is if it's more than a day, then I need to break it apart into smaller pieces until I can make estimates that are in hours of each piece, and then I'm more likely to get an accurate estimate.
Yeah.
Oh, how do you see the so sometimes we have situations where we say, okay, we want to accomplish X, and we estimate how much time it's going to take to accomplish X. Other times we see where it comes in and they're like, okay, we have until this date to accomplish a certain task. how do you see that playing out differently? I mean, is that a matter of okay, well, then we're taking on technical debt to accomplish this, or is there a better way to handle that when it's purely deadline driven?
I'm not sure I understood the question. Would you mind rephrasing that?
So, if you have a situation, so we have situation A where you're like, okay, we want to accomplish a certain thing, a certain task, create a certain product, and
Okay.
you do go through a rigorous estimation process to say, okay, that's going to take this much time. We estimate it'll be released by this time, right? So we come up with that a deadline or a target date through rigorous estimation process. Other times we come up with things. We had Uncle Bob yesterday. He talked about the healthcare website, right? And they're like, okay, it's going to be released by this date, and they turn it over to the programmers, and it didn't get there because there was no estimate in the, it was purely driven by politics for the date. So
Right.
how do you see that unfolding? What's the best way to deal with that? Is that really just hey, if we got to accomplish X by Y, then we're going to take on Z technical debt to do it, or is there a better way to deal with that sort of deadline-driven situation?
Yeah, for anybody who's interested in that Understanding Software Projects lecture series, I talk about the healthcare.gov website extensively in one of those lectures. There's just, that's an extreme case where there was no way you were ever going to solve or reconcile the plan schedule versus the amount of work through taking on technical debt. The gap was just too big to close. So, I think that's a case where that because that was a government project, there were, politics in the strongest possible sense involved in the creation of that particular project. I think for more common kinds of project contexts where maybe you're working on a software project in-house and the stakeholders are mostly internal, then I think that I have found it really useful to differentiate between what I call estimate, target, and commitment. Where we try to keep the estimate clean as a purely analytical assessment of how long something will take or how much it will cost or how many features we can deliver in a certain amount of time. The target is a statement of desirability. What would it be? What do we want to have? And then the commitment is what we agree to try to accomplish together. And I think that businesses will often define targets and then declare that with no real analytical process, declare that to be the estimate. And that's not rational or constructive to do that. And I think project teams sometimes will engage in pretty unproductive dialogue with their business partners where they'll give an estimate and the business partner will say, well, here's the target we really want to have and it has to be that. And the project team will just accept that. And I think in a lot of those conversations, the word estimate is used to mean variously estimate, target, and commitment. And so I think if we can be kind of clear about the terminology and say, all right, it sounds like you're defining a business target, you really want it to be done, or there's good reason for the business to want it to be done by this particular date, or to have, this much functionality delivered by the date, or to have it cost an amount X or Y or Z. And given that, we've taken a look at it, and here's our estimate for how long it will take or how much it will cost. So let's talk about the fact that the target and the estimate aren't the same, and what do we want to do about that? Those can be kind of productive conversations, and they aren't necessarily fun conversations, but I think one of the problems that technical people have is that they want to give this business, we're invariably in the situation of the business staff asks for more than it's going to get, then more than it's possible to give them, more than it's possible for us to deliver within the constraints they define. And so we're invariably in the situation of going back and telling the business staff that we can't give you what you wanted, we're not going to be able to hit the target you defined. And that's fine. I think that's healthy back and forth, and the business needs technical staff to play its role of being knowledgeable about the delivery capability of their team or their organization. It's important that we actually do that, perform that role. And I think sometimes we find ourselves wanting the business stakeholder to be happy when we give them bad news, and I don't think that's rational or realistic. I think we should just expect that when we go back and tell them, look, we're not going to be able to give you everything you want, they're not going to be happy about it. But we can also expect that they're going to act like grown-ups and get over it And if we can be productive and constructive in the way that we deliver that message and say, okay, well, we can't give you exactly what you wanted, but here's what we can give you, we can expect them to act like adults and work with us to try to figure out what the best available solution is. But we shouldn't expect them to be happy and immediately accept that they can't get what they want. We should expect that they're going to spend some time querying us and probing us and really trying to explore, is there some way we could get what we want? And we just have to go through that process. It might not be very fun or comfortable, but it's important that we actually play our role on the technical side so that the business overall makes a good decision about the combination of the resources it's going to spend, the business target it's going to go after, and basically what the odds are of us actually being able to deliver on the plan. And I think the technical staff, technical leadership's role in those scenarios is really to be the party that's knowledgeable about, are we going to be able to deliver on the plan, or what plan is going to work the best.
It's interesting, the next few questions I had here kind of played in exactly what you were just talking about. So there was a question here, how do you recover from bad estimate to a client, which you kind of said you kind of got to go back and provide a constructive feedback. I can't do this, but I can do this, and just be knowledgeable in that. And then how can developers avoid managing up, acting to please their managers, and avoid backing themselves into corners of missed commitments? And so,
yeah.
I don't know if you had anything else you wanted to add to that, or otherwise I got another question here for you.
No, go ahead.
Okay. Do you see lines of code as a good indication of technical debt? As in, less code is less debt?
I think I would say that as the years go by, I think, if we were talking about this 10, 15 years ago, I might still be trying to make an argument in favor of lines of code being a meaningful way to measure software functionality. I think as the years have gone by, I have focused less and less on lines of code as being a useful way to measure anything. It's not to say that someone who's really skilled at it couldn't find a way to do it and do it well. It's just that I think there are other ways to make those measurements that are probably easier and more meaningful. So yeah, I think there's probably some relationship there between lines of code and amount of debt, but I think it's a pretty loose relationship. I mean, and I think there's still a place for static code metrics like cyclomatic complexity and that kind of thing. It doesn't necessarily, it's not really decisive, but it can give you some guidance about, well, what areas in the code should I look at, and if I see some place that has really high cyclomatic complexity, that's at least a clue that I want to go in and take a look at that and see if there's something going on there that shouldn't be. And it might be fine, but it might not. So it more guides inquiry than is really decisive.
Okay.
And I suppose maybe part of that, what's implied in that question too, is things like super long classes or super long routines. I think there are outliers that clearly represent high technical debt. I think I gave examples during the presentation about one stored procedure that was 15,000 lines long, and one system that had 500,000 lines of code in one class. When we get into situations like that, yeah, at a very coarse, gross level, lines of code, I think, can be a symptom of high technical debt.
Yeah, it kind of reminds me of those examples remind me of, and actually I think I've worked on both those projects. But It reminds me of the idea of code smells, right? And I've been in projects where there's like one module no one wants to touch because you get there and it smells so bad, right? And it just takes so much effort to try and deal with the complexity of the way it's written and that being so in need of work.
Yeah, I'm not sure I've ever seen a project that didn't have one module that everyone was afraid of. It project probably exists somewhere, but I haven't seen it.
Yeah, yeah, yeah. I remember the day when someone finally took the time to clean that module up, and it was pretty amazing. Let's see here. Mark's saying usually it's the salespeople that just say what budget we have and what we need to get done within that budget, even if it's not reasonable. It's also that customers are non-technical and cannot appreciate what building and designing software is complicated and a time-consuming thing. They cannot take a complex business rule for granted and be super overwhelmed by a simple new theme color in software. Yeah, so they tend to value the wrong things as far as what's involved in them.
Yeah.
Have you found any good ways as far as delivering bridging that gap between the technical understanding of that estimate and the delivering that to the customer's right? So the customer's like maybe thinks, like you're saying, the theme that's a big deal because I can see it, but they don't understand necessarily the complexity of a business rule. When you deliver an estimate around, well, this change is going to take this much time, but this change is going to take less. How do you manage? What's a good ways to manage that?
I'm not sure I have a very complicated answer to that. I think it's really just a matter of having the conversation. I'm not sure there's any. I mean, maybe there's a nuance to that question I'm not picking up on, but a lot of this says the answer is kind of implicit in the question. I think the customer doesn't understand the ins and outs of it, and so we really need to try to explain the ins and outs of it to the customer, and and I think do it in a non-condescending, problem-solving manner where we're just trying to develop more shared understanding. Is there a nuance in that question maybe that I'm overlooking, you think?
I think that's probably the answer right there. Is just it's a matter of having that conversation and explaining it in a non-condescending way. I think that's it's one of those things that oftentimes just communication is the answer, right? Having that conversation, taking the time to do what needs to be done.
Yeah.
There isn't a silver bullet for it.
Yeah.
Okay. It was interesting actually when you were talking about your estimation, and I meant to mention this then, but then got distracted with another question. I think I just watched the session where you pulled up what's the definition of estimate? We're using estimate in the wrong ways to mean more than it really is, right? We're using estimate to say that's the deliverable date instead of that's our best guess, right? Our educated guess for when it's going to be.
Mm-hmm.
Okay, well, it looks like we're about done here for questions. I really appreciate your time, Steve, and coming out and being part of CodeRage today.
Yeah, it's my pleasure. Happy to do it.
It's when I was planning CodeRage this year, I'm like, well, the two people I would love to have be part of it would be Robert Martin and Steve McConnell, and I told everybody this is what I want to have. They're like, oh my goodness, that would be great, and you're both here, and so I'm pretty excited about that.
Very good. Glad to hear it.
I always say when I was talking to non-technical people, I'm like, how excited I am to have you guys here, and I'm like, if you ask any developer what's the books that all developers should read, and they'll say Code Complete and Clean Code are going to be on their list of their top 5, top 10, whatever,
Mm-hmm.
and so it certainly is a pleasure to have you here, and it's great to find out that these books that were written a while ago continue to be relevant, and that you continue to be involved in the industry and continue to be providing this kind of leadership in educating developers on how to hone their craft better. All
right. Well, it's been my pleasure.
So thank you very much. And if people want to catch up with you, they can go to constructs.com and check out your on-demand. And now, you said the new courses each week are free. Are those on YouTube, or are they on the on-demand site to catch those?
They're definitely on the on-demand site, so they need to go to ondemand.constructs.com.
And then is it a subscription program, or how does that work beyond if they want to go beyond the free sessions?
Yeah, it ends up being basically an annual fee, and there's a lot of free content out there. If they just sign up, they can access the free content. And if anybody wants to sign up for all of the content, which there's quite a bit of, then it's an annual subscription model.
I see there's a Code Complete Essentials course.
Yep, so it's basically software development best practices. So we've got Code Complete, we've got Scrum in-depth class, we've got software estimation in-depth, product owner boot camp, we've got a Scrum overview, we're working on Kanban class, Agile planning and estimation, Agile release planning, developer, we've got a Agile developer boot camp class, so all kinds of stuff out there.
And I see there's a number of other trainers beyond you on here,
Yep.
But you're in the Code Complete and this Understanding Software Projects.
Yep, and I also do the estimation class.
And the estimation. I was going to say probably the estimation one, although I didn't see your name on there. So, well, thank you. I got some people coming here, just positive feedback. Really appreciate your book, your time, and all that you've done in the industry to help make our jobs and our lives better. So, thank you very much, Steve.
Oh, thank you.
All right, we'll catch you later. Bye-bye.
All right, bye-bye.